Now, in this video, we're going to answer the following question. Determine which vectors below are parallel. And we've been given 4 vectors. A equal to 2, 3 in a square bracket. B equal to -1, 5 in a square bracket. C equal to 3, -15 in a bracket. And D equal to 4, 6 in a square bracket. If you find this video useful, please consider leaving a like, a comment, and subscribing to our channel for more content like this. A vector is a quantity that has both magnitude and direction, as opposed to scalars, which are quantities that only have a magnitude. 2 vectors are parallel if one is a scalar multiple of the other. That means we can multiply one vector by a number to get a parallel vector, or we can divide 2 vectors and get a scalar multiple. The vectors A, B, C and D are written in this question as coordinate vectors in square brackets. We can divide these vectors by dividing each element of one vector by the corresponding element of the other vector. When their ratios are equal, the vectors are parallel. So let's divide vector A by each of the vectors B, C and D. A divided by B is equal to 2 divided by -1 for the x component and 3 divided by 5 for the y component, which is equal to -2, 0.6. And because the ratios are unequal, these vectors aren't parallel. A divided by C is equal to 2 divided by 3 for the x component and 3 divided by -15 for the y component. That's equal to 0.67, -0.2. And because the ratios are unequal, these vectors are also not parallel. A divided by D is equal to 2 divided by 4 and 3 divided by 6, which is equal to 0.5, 0.5, and because the ratios are equal, these vectors are parallel. So vectors A and D are parallel. Let's test the other vectors the same way and see whether they are parallel. C divided by B is equal to 3 divided by -1 and -15 divided by 3, which is equal to -3, -3. And because these ratios are equal, these vectors are also parallel. So vectors B and C are parallel. This isn't the only test for whether vectors are parallel. We can use a property called the dot product to determine whether vectors are parallel. If vector A dot vector D is equal to the magnitude of A multiplied by the magnitude of D, vectors A and D are parallel. Let's test this with vectors A and D, which we know already are parallel. First, we need to write them in their ij component form. A is equal to 2i plus 3j, and D is equal to 4i plus 6j. First, let's multiply vector A with vector D. A dot D is equal to 2 multiplied by 4, which is the product of their I components, plus 3 multiplied by 6, which is the product of their j components, and that's equal to 8 plus 18, which is equal to 26. Now let's find the magnitude of A and D. The magnitude of A is equal to the square root of 2 squared plus 3 squared, which is equal to the square root of 4 plus 9, which is equal to the square root of 13. The magnitude of D is equal to the square root of 4 squared plus 6 squared, which is equal to the square root of 16 plus 36, which is equal to the square root of 52. The square root of 13 multiplied by the square root of 52 is equal to the square root of 676. And the square root of 676 is 26. Both values are 26, so vector A dot vector D is equal to the magnitude of A multiplied by the magnitude of D, and therefore A and D are parallel. So the answer to this question is A and D are parallel vectors, and B and C are also parallel vectors. If you found this video useful, please consider leaving a like, a comment, and subscribing to our channel. Thank you.